Welcome back, everyone. So in the second part now, we are going to do another quick warm up on P's and Q's because that's really important that you understand how that game works in order to be able to factor what we do today. And then we're going to actually look at 3 methods for factoring a trinomial, meaning 3 terms with a leading coefficient that isn't 1. Those methods are supergrouping, double cross, and slip and slide. They all kind of have funny names, but then after you practice each one, you will get to choose what method you like the best, and you can use that method on your worksheet practice later on. So without further ado, let's start off with our warm-up. Factor each by P's and Q's. So again, these are trinomials with a leading coefficient of 1. So there's no number here in front of the x squared, there's no number here in front of the n squared, which means we just get to play the P's and Q's game, and that's how we're going to factor. Go ahead and pause the video now if you want to try this on your own. All right, so hopefully while you were doing this, you know that our answer is going to be a product of 2 binomials. Now the first term in each of these binomials is going to be what times what gives you the first term in the trinomial. So what times what is n squared? That's n times n. And what times what is x squared? That's x times x. Now we play the P's and Q's game. What 2 numbers have a sum of the middle term and a product of the last term? So in this case, we're saying what 2 numbers have a product of -20 and a sum of, what do you think the sum would be here? Hidden 1. What plus what also equals 1. And we play the game. So we start thinking about all the different products for -20. 2 and 10, well, those are 8 away from each other, so probably wouldn't get a sum of 1. 4 and 5 are 1 away from each other. But if the sum is +1 and the product's -20, which one is positive, 4 or 5? Let's try making 4 positive first. 4 times -5 is -20. 4 plus -5 is -1, so we're really close. All we have to do is switch the negative over to 4. -4 times 5 is -20. -4 plus 5 is 1, so our 2 numbers are -4 and +5. And that's how you play the P's and Q's game to factor. Now, we would normally multiply to check, but for sake of time, I'm just going to let you know that that is correct. Yay! And we're going to move on. Over here, second example. It is a trinomial, leading coefficients 1. That's how we know we can use P's and Q's. So we play the game. What 2 numbers have a product of 6 and a sum of -5? So what times what equals 6? That when I add them together, I get -5. So I start thinking about products of 6. 6 and 1. But 6 plus 1 is 7. That's not close to 5. 2 and 3. 2 times 3 is 6. And 2 plus 3 is +5. So how do we get -5? What if we made them negative? -2 times -3 is still +6. -2 plus -3 is still -5. So my answer is -2 and -3. Now, order does not matter. You could have also said n plus 5 times n minus 4. That's fine. You could have also done x minus 3 times x minus 2. That's also fine. But this is called factoring with P's and Q's. If you cannot factor with P's and Q's, today's going to be very difficult for you. But I know that you all can, so we're going to be just fine. Get your notes ready. We're going to go over, again, 3 different ways to factor a trinomial, so 3 terms, with a leading coefficient. The number out in front is not 1. Get your pen and pencil ready now. All right, so the question that's going to drive our instruction this morning is, how do we factor something that looks like this? 2x squared plus 11x plus 12. Let's see if we can do a GCF. So is there a GCF, a greatest common factor of 2, 11, and 12? Unfortunately, other than factoring out 1, which in this case doesn't help us, there isn't one. You could factor 2 out of 2 and 12, but 2 doesn't go into 11. GCF factoring, not going to work. Let's try factor by grouping. Can't do factor by grouping because you need 4 terms to be able to factor by grouping, and this has 3. Let's try P's and Q's. Can't do P's and Q's because the leading coefficient isn't 1. So of all of the methods that we've learned for factoring, none of them work on this guy. So we need a different method. In fact, there are 3 different methods that I know about to factor a quadratic expression, a trinomial like this one. They are, again, supergrouping, double cross, and flip and slide. We're going to start by looking at supergrouping. Here we go. So the reason why I called this supergrouping is because you will actually do factor by grouping here. But in order to do factor by grouping, we have to have 4 terms. So what's essentially going to happen is we're going to split this middle term into 2 terms. So 11x, like we could split it up into like 10x plus 1x, or we could split it up into 8x plus 3x, or we could split it up into 7x plus 4x. You get the idea. We're going to split this up into 2 terms to turn this trinomial into a 4-term polynomial. From there, we can factor by grouping. But we have to find the right combination that allows us to split up this term so that factor by grouping actually works. So to do that, you're actually going to start off by playing the P's and Q's game, but you're going to play it a little bit different. So to play the game in this case, you're still going to ask yourself, what 2 numbers have a sum of 11? So it's still always a sum of the middle term, but this time it's not what 2 numbers have a product of 12. It is what 2 numbers have a product of 24. Now, how am I getting that? I'm getting that by taking the first coefficient and the last coefficient and multiplying them. So 2 times 12 is 24. So now we're playing the game a little bit differently. So now instead of what 2 numbers have a sum of 11 and a product of 12, it's what 2 numbers have a sum of 11 and a product of 24. And again, we got 24 by multiplying the first and the last term. So now we play the game. We're sitting over here to the side and we're going, okay, what 2 numbers, let me grab a different color here. What times what equals 24, that when I add them equals 11. So I start thinking about all the different ways to get 24. 6 times 4. Well, 6 times 4 is 24, but 6 plus 4 is 10. 12 times 2. 12 plus 2 is 14. 8 times 3. 8 plus 3 is 11. So we know that my values of P and Q are 8 and 3. 8 and 3. Now you might be thinking to yourself, why the heck did we just do that? Well, I told you at the beginning what we're trying to do. We're going to break up this middle term to change this into a 4-termed polynomial so that we can do our supergrouping. So here's how we do that. Watch. We're now going to take the middle term and we're going to split it up into 8x plus 3x. Where did I get 8 and 3 from? I got it from playing the P's and Q's game, because those are the 2 numbers that have a sum of 11 and a product of 24. So we've successfully broken up 11x. What do you think our first term is going to be? It's going to be 2x squared. That doesn't change. So we have 2x squared plus 8x, which we just brought that down. And our last term is going to be plus 12. Now, if you're sitting here confused, I want to explain to you what we just did. All we did was we took a trinomial and we decided to write it as a polynomial with 4 terms. Does 8x plus 3x still equal 11x? Yes. So we haven't changed the value of the expression. We've just changed the number of terms. Well, what does this allow us to do now? It allows us to group, because we can only do factor by grouping if we have a 4-termed polynomial. So here we go. Step 1, put it into groups. Well, notice that it is addition here, so I can just go ahead and put my groups in right away. Ta-da! Step 2, find the GCF. So of 2x squared and 8x, I know 2 goes into both. So this is 2 times x, and this is 2 times 4 times x. What do they have in common? They have a 2x in common. So that goes out in front, 2x. What am I left with when I take out that 2x? Well, let's see. I'm left with x in the first term and positive 4 in the second term. Now again, when we do factor by grouping, we're going to look ahead. Our goal is to get x plus 4 as our second binomial. So when we're looking to factor out the GCF here, our goal is to get x plus 4. So let's look at this one. What is the greatest common factor of 3x and 12? I know 3 goes into both. This is 3 times x. This is 3 times 4. Since they both have 3 in common and it's a positive 3, I'm factoring out a positive 3. And I'm left with, look at that, x plus 4. Final step, factor out that common binomial factor that they both have. They both have x plus 4. So whatever they have in common goes out in front, x plus 4. And then look at what's left over once you take that out, 2x, which was the GCF of the first two, plus 3, which was the GCF of the second two. That's how you factor 2x squared plus 11x plus 12 using supergrouping. Again, just to review, we played the P's and Q's game, but with a slight twist. Instead of finding a product of the last term, we found a product of both of them. So we did what two numbers have a sum of 11 and a product of 2 times 12. Then we split the middle term into those two numbers, 8 and 3, and factored by grouping. That's why we call it supergrouping, superhero stance. All right, that is one possible method. So if you're looking at this and you're like, yes, that makes sense, feel free to totally disregard the rest of this video. If you're looking at this like, what on earth is she talking about? Don't worry, there are 2 other methods for factoring an expression that looks like this. And we will make sure to go over more examples with supergrouping for those of you who actually like it. On to method 2. All right, time for method number 2, called double cross. So you'll notice it's the exact same trinomial that we just did with our supergrouping. So we know what our answer should be. We should end up with x plus 4 times 2x plus 3. To do this method, the reason why it's called double cross is that you're going to, underneath your trinomial, set up a kind of a weird looking x. Let me show you what I mean by that. You're going to kind of draw like a horizontal line, and then you're going to put the x and another horizontal line. Now the horizontal lines should be underneath the first and the last term. I'll show you in just a moment why. And then that's only one, so the other double cross part is horizontal line, continue your x, horizontal line. Okay, that's kind of the setup for double cross. Now here's how this works. These 2 terms have to multiply to get the first term. So in other words, these 2 terms have a product of 2x squared. These 2 terms have a product of 12. So in a weird way, it's also kind of like P's and Q's. So these 2 terms have a product of 12, but there's always a catch. The middle term, 11x, is always the sum. So you still need to have a sum of 11x, but you're going to put it down here for me, and I'll show you why in just a moment. So we're just kind of setting this up, getting it ready for when we go. Now, here's where it gets a little weird, if it wasn't weird already. So what times what is 2x squared? X times x is x squared. So I know that they both have to at least have an x. And then what times what is 2? Well, luckily for us, in this case, there's only one way to get 2 using multiplication, 2 and 1. So I'm going to put 2x here and 1x there, because 2x times 1x is a product of 2x squared. Now, there's a bunch of different ways to get 12. You can get 12 using 6 and 2. You can get 12 using 3 and 4. But here's the catch. If you notice, there are these kind of lines going across here. The way that we're going to get these terms over here is whatever numbers go in these spaces, you're going to multiply it from what is across from it, and that will give you a term off to the side. Let me show you what I mean by that. So we're going to do a little bit of trial and error and see if we can come up with the numbers that when I multiply, get a sum of 11x. So let's see what times what is 12. What if we tried 6 and 2? So if I put 6 here and 2 here, 6 times 2 does equal 12. So already I'm looking pretty good. But I need to have a sum of 11x. So here's what we do. You're going to start with the top term. You're going to trace it down and you're going to multiply. What is 2x times 2? That's 4x. Okay, so I'm just trailing along. 2x times 2 is 4x. Same thing here. 1x times 6 is 6x. Do these two, when I add them together, give me a sum of 11x? Let's see. What's 6x plus 4x? Darn, that's 10x. That didn't work. So I know my answers can't be 6 and 2. Well, maybe I can just switch them. Maybe I can go like this. You never know. Let's see if that works. Now, let's see what we end up with. Let's put up some new spots here. 1x times 2 is 2x, okay? And 2x times 6 is 12x, okay? Does 12x plus 2x equal 11x? No. So I know that my numbers are not 2 and 6. That did not work. So let's try something else. If 2 and 6 don't work, what other numbers multiply to get 12? How about 3 and 4? 3 and 4. So let's say, or 4 and 3. Let me put the larger one here. Let's put 4 here. And we'll put 3 here. This is a guessing game, which if you're good at guessing games, then you will like double cross. If you're not good at guessing games, you will not like double cross. All right, let's see. Okay, let's see if that worked. 2x times 3 is 6x. 1x times 4 is 4x. Does 4x plus 6x equal 11x? No, but does that mean that 4 and 3 are wrong? Not necessarily. Let's try switching them. Put 4 down here and 3 right there. Let's see what that does. I'm going to run out of Post-its here pretty soon. All right, let's see if that changes things. 1x, oh, start up here. 2x times 4 is 8x. 1x times 3 is 3x. Does 3x plus 8x equal 11x? Yes, it does. That means we found our correct numbers. Yay! So what we're going to do with that is I'm going to take out the Post-its and actually write in the numbers. So we found that this number is 3 and this number is 4. And those were, again, for the sake of what's going to happen next, we're talking here a positive 3 and a positive 4. There is a reason why I'm putting the sign right there. That produced, come on, a 2x times 4 is positive 8x, and 1x times 3 was positive 3x, and when we add them together, we got 11x. So why did we do all of that? Well, you may not see it, but you just found your 2 binomials. Your first binomial is 2x plus 3. See where I got that from? Just by looking across here. So my first binomial is 2x plus 3. What do you think my second binomial is? 1x plus 4. But again, think about your future Algebra 2 teachers. They're not going to want you to write 1x. What's 1 times x? simply x plus 4. Is that what we got when we solved it using supergrouping? Yes, it is. This method is called double cross. If you don't like double cross and you don't like supergrouping, there is one final method called slip and slide that we're going to go over right now. All right, here we go. Same trinomial, 2x cubed plus 11x plus 12. This time we're going to do our third method called slip and slide. Now, when I taught Algebra 1 last term, so in the fall, slip and slide was a favorite method from those students, and it's something I actually learned on a YouTube video, ironically enough. None of my previous students before this year ever got slip and slide. So you are in for a treat if this is something that you might like. So slip and slide is for those of you who really enjoy the P's and Q's game. If you do not like the P's and Q's game, you probably are going to want to do double cross or super grouping. So here we go. Notice how it's called slip and slide. So the first step is we're going to slip. The slip means we're going to take this 2 and we're going to slip it on down to the end here and multiply. So basically what we're doing is we're doing 2 times 12. Very similar to supergrouping. So once we slip that 2, that leading coefficient down to the end, that's going to give us a new trinomial. So our new trinomial that we're working with, I'm going to put it in quotations because this isn't our actual trinomial. This is just what's happening in the process. Our new trinomial is going to be x squared plus 11x plus 24. Because when I slip the 2 down to the end, that 12 becomes a 24. Very similar to what we were thinking when we were doing supergrouping. But again, this is not your new trinomial. This is not even necessarily equivalent, which is why I'm putting it in quotations, because this is just what we're going to use to get our final answer. So that's called slip. From here, what you might notice is that now it's a trinomial with a leading coefficient of 1. What can we use to factor a trinomial with a leading coefficient of 1? We can now use the standard P's and Q's game. So I find 2 numbers that have a product of 24 and a sum of 11. And I know what my quote binomials are going to look like already. So I'm going to set them up. I'm going to put them in quotes again, though, because this is not going to be my final answer. This is just the process of how you get from this step to this step. So I know my answer is going to be a product of 2 binomials. What times what gives me x squared? I know it's going to be x times x. These are still in quotations, though, because it's not going to be your final answer. I'll show you why afterwards. All right, let's play the game. What times what is 24 that when I add them together gives me 11. Now, if we've been following along, we actually already did this work with supergrouping, and we know that our numbers are 8 and 3. 8 and 3. So we're going to take those numbers and we're going to put them into our binomials, positive 8 and positive 3. This is not our answer, because if you recall from supergrouping back here or from double cross, our answer was not x plus 8 times x plus 3. That's how you would get this trinomial, which is not the trinomial that we started with. So notice how this is not just called the slip method, it's called the slip and slide method. So what you're going to do, notice how we slipped the 2 to the end. We're now going to slide that 2 back underneath. So once it was slipped to the end, now we're going to slide it back. And you're basically going to put it underneath these 2 terms. Essentially what's happening is because you multiplied it, you have to now undo that math by dividing it. So since we multiplied it by 12, we're now dividing it by the 2 last numbers. And then you simplify your division, which is kind of possible and kind of not. So here's how that works. Can I actually simplify 8 divided by 2? Yeah, 8 divided by 2 is 4. So now I'm going to take out the quotations because we're going to end up with our final answer. Our final answer is going to be a product of 2 binomials. Here we go. 8 divided by 2 is 4. So this means this simplifies to x plus 4. Wait a minute. Wasn't x plus 4 in our final answer? Yes, it was. Now here's the problem with this one. I can't actually divide 3 by 2 fully. So when you can't divide, think of it like this. To get rid of a denominator, I can multiply both of these terms by 2. Well, multiplying this by 2 would leave it as a positive 3. And multiplying this by 2 would change it into a 2x. In other words, because I can't divide this, I'm just going to slide it out in front. And that's our final answer, which matches the other answers from the other two methods. So this method is called slip and slide. Again, you slip the leading coefficient to the end, put your new one in quotations because that's not your actual trinomial, play the P's and Q's game, slide it back underneath, and then simplify the quotient if you can. If you can't simplify the quotient, then you just slide it back in front, or you multiply both of the terms by the denominator. Bada bing, bada boom, slip in, slide. All right, we're gonna do an exit ticket where we're gonna look at another example, and we're gonna do all three methods with that example, just so that you get a little bit of extra practice. Okay, for our exit ticket, we are going to factor 3x squared minus 10x plus 8. Can we do GCF factoring? No. Can we do factor by regular grouping? No. Can we do factoring by regular P's and Q's? No. Why not? Because it is a trinomial with no common factors and the leading coefficient is not 1. So that means those three methods are out. So we have three new methods to choose from. We can do factor by supergrouping, factor by double cross, or factor by slip and slide. I'm going to do all three, starting with supergrouping, then double cross, then slip and slide, and then you'll get to choose which one that you prefer. So let's start with supergrouping. What did I just hit? Supergrouping. Okay, so for those of you who liked supergrouping, here's what we did first. It's kind of like playing the P's and Q's game with a little bit of a twist. So I'm going to start by rewriting this because I'm going to do my supergrouping a little bit different. So 3x squared minus 10x plus 8. I'm actually going to write it below to give myself a little bit of room to do my P's and Q's. Okay, so if you remember how supergrouping works, our goal is to split up the middle term to create a 4-termed expression that we could then do grouping on. So we do play the P's and Q's game with a little bit of a twist. It's what two numbers have a sum of -10, but the product is the first term times the last term. 3 times 8 is 24. So now we're going to play the P's and Q's game, but it's what two numbers have a sum of -10 and a product of 24. And we're going to play the game. What times what equals 24, and what plus what equals -10. All right, let's see. Products to get 24, 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. That's not close. 12 and 2. 12 times 2 is 24. 12 plus 2 is 14. No. 4 and 6. 4 times 6 is 24. 4 plus 6 is +10, which means we're close. Let's see if we can get even closer. 4 and 6. 4 and 6. How do I get -10? Make them both negative. Let's see. -4 times -6 is +24. -4 times -6 is -10. Now, don't forget our goal right now. It's called grouping for a reason. We can't, like P's and Q's, we can't just jump into a factored form. The reason why we did that was because we're going to split the middle term to create a 4-termed expression. So here we go. We're going to split -10x. into negative 4x and negative 6x. Where did I get those from? I got those from my P's and Q's. And again, it doesn't matter the order. You could have also done negative 6x and negative 4x. Bring down the first term, 3x squared. Bring down the last term, positive 8. Now it's just factor by grouping, which you have done quite a bit over the last 48 hours. All right, I see subtraction here, which means I need to make sure that when I put my groups in that I account for that subtraction. So in my first group, I have 3x squared minus 4x. In my second group, I have negative 6x plus 8. Now I do my GCF factoring. What is the greatest common factor of 3x squared and 4x? Well, 1 is the only thing that goes into 3 and 4, but they also have an x in common. So this would be 3 times x times x. This is negative 4 times x. They have that x in common, so let's pull that x out in front. Let's factor out x. Boop. I'm going to run out of room. Okay, when I factor out x, what does that leave me with? That leaves me with 3x in the first term and negative 4 in the second term. So first one, x times 3x minus 4. Same thing over here. What is the greatest common factor of 6x and 8? Wait a minute, I made this mistake earlier. It's a negative 6x, not a positive 6x. So we have to factor out a negative. So what goes into negative 6 and 8? Negative 2. This is negative 2 times positive 3 times x. Positive 8 is negative 2 times negative 4. Keep that in mind because that's a positive 8. Factor it out. They have negative 2 in common. So we're factoring out a negative 2. And when we do that, that leaves us with 3x minus 4. Does that match? Huzzah. Okay, last step. Let's write it out as an answer. So our common binomial factor is 3x minus 4. And remember, once you take that out, what do you have left? You have x as the GCF of the first term and negative 2 as the GCF of the second term. And that's our final answer, or at least what we think is our final answer. In order to check, instead of multiplying, we're just going to do the same problem, but we're going to do it using double cross, and that will be our check. But that is super grouping. And then after you do it, you have to do a superhero pose. I'm just kidding, you don't have to do that. Some of you will. Okay, here we go. Exit ticket part 2. Same expression. Now we're going to do it with double cross. Which, fun fact, double cross is also known as the McDermott method. The reason why it's known as the McDermott method is because Mr. McDermott was the one who taught it to the rest of the math department. True story. All right, double cross. So we're going to start by setting up our double cross structure. Horizontal line, crossing through, horizontal line. We're trying to find two numbers that multiply to this first term, multiply to the last term, and have a sum of negative 10. So we're going to set up our sum over here, negative 10x. So before you do anything, you always want to set up your double cross structure. All right, here we go. The nice part about having a whiteboard is that I can kind of do guess and check without having to like erase my work. Or if you have Post-it, that's a really good way too, or just work in pencil. All right, these two terms have to multiply to get 3x squared. So I know at least they both have to have x, because x times x is how we get x squared. What times what is 3? How about 3 times 1? And that's the only way to get 3x squared. So the hard part with double cross is when this becomes like an even number, like 4, because like there's more ways to get 4, 2 and 2, 4 and 1, but hopefully we won't run into that. All right, so 3x times 1x is 3x squared. Now it becomes the guessing game. What two numbers have a product of 8, but they have to have a sum of negative 10? So the first two numbers that come to mind for me are 4 and 2. So let's see what happens. If I put 4 here and 2 here, let's see if that works. 3 times 2 is 6. 3x times 2x is 6x. 1x times 4x is, or 1x times 4 is 4x. What's 4x plus 6x is positive 10x. Oh my gosh, I'm so close. How do I get negative 10x? What if instead of making these both positive, I made them both negative? That would be 3x times negative 2x, which is negative 6x, and 1x times negative 4x, which is negative 4x, and negative 4x plus negative 6x is negative 10x. I got it on the first try. I wasn't even trying to do that. I was trying to make a mistake, and look how well that turned out. All right, now from here, we can pull out our two binomials. If you remember from the notes, our first binomial is right there, 3x minus 4. Our second binomial is right here, 1x, which we know is just x, minus 2. Is that also what we got when we did our super grouping? I took a picture of it, 3x minus 4x minus 2. That's also what we got. So we know that either we did both of them wrong, or more likely we did both of them right. The way to be triple sure is we're going to end our exit ticket with slip and slide. Same quadratic, same trinomial, doing slip and slide. Okay, final part of our exit ticket, same quadratic. This time we're going to do slip and slide. Slip is part 1, slide part 2. Remember, slip and slide is for those of you who like the P's and Q's game. So step 1, we're going to slip the leading coefficient down to the end. That means we're going to basically multiply 3 times 8. That's called the slip. Now, from here until the very last step, everything is a quotation because we're not actually changing the trinomial. We're just working with it in a different way. So make sure that you understand that once you slip that down there, you're no longer working with an equivalent trinomial. You're working with something that looks a little bit different. So I'm thinking now, my trinomial just became x squared minus 10x plus 24. And I'm putting it in quotations because that's not actually what it is. From here, I play the P's and Q's game. What two numbers have a sum of negative 10 and a product of 24? And I actually already know the answer to that because you play a very similar game when you do double cross, or excuse me, when you do super grouping. So what two numbers have a sum of 24, excuse me, a sum of negative 10 and a product of 24? If you remember, those two numbers were negative 4 and negative 6. Now, unlike super grouping, because this is P's and Q's, we can just put this straight into our two binomials. Oops, we use the same color. Our hypothetical binomials. These are still set up in quotations. In fact, I probably should have done this step first. We know that our first terms are going to be x and x, and we're going to put in negative 4, and we're going to put in negative 6. Now remember, that is just the slip, and this is not my answer. This is how I multiply to get this trinomial, which is a hypothetical. This is what we're working with. This was my real trinomial that I started with. So it's called slip and slide for a reason. The last step before we're finished is we're going to take that 3 that we slipped toward the end, and we're going to slide it back underneath. So we're essentially dividing both of these terms by 3 because we slipped it down and we multiplied. So to undo the slip, you got to slide it underneath to do the division. Final step. If it's possible to do the division, you're going to do it. If not, think of it as you're just going to rewrite it by multiplying both terms by 3, or in other words, sliding that 3 in front. So I look at this and I'm like, okay, I know I can do 6 divided by 3. So I'm going to do that part first. Now I am coming back to my regular expression now. So no more quotations. This binomial simplifies to x minus 2. But this binomial, 4/3, is not simplifiable. So instead, if I multiplied both of these by 3, this would become just -4, and this would become 3x. Or in other words, I'm just sliding that 3 out in front. Now, is this what we ended up with when we had double cross and supergrouping? Let me check my picture. 2x, oops, wrong one. 3x minus 4, x minus 2. Yes, it is. So it didn't matter which method we used. We ended up with the same answer for all 3. All right. That is the end of our instruction. In addition to posting this instructional video, I'm also going to post pictures of each poster with each exit ticket example. Your goal today is to attempt the worksheet practice doing whatever method you want. I don't expect you to do all 3 methods on every single problem, but I do recommend that you try each method at least once to find out which one that you like the best. Along with the worksheet practice will be a survey for you to fill out to give me feedback so that when we do our Zoom conference call tomorrow, I will be able to help you with any questions that you have. Have fun factoring, and I will see you tomorrow.